Alrighty, find the second derivative. Well, hold up. Before you find the second derivative, you have to find the first derivative. And since this function is not explicitly defined for just y, we will use implicit differentiation. The derivative of x squared is 2x. The derivative of y squared, that's 2y times either y prime or dy dx, and the derivative of 81 is 0. Now that we have differentiated, we would want to collect all of the y prime terms, there's only one, and isolate y prime. So let's move 2x to the other side. When we do, we've got 2y, y prime, is equal to negative 2x. Divide by 2y. Okay. So, these 2's cancel, the y's cancel, these 2's cancel. We find that y prime is negative x divided by y. This is our first derivative. Okay. Now that negative, it can be at the top, it can be at the bottom, it can be on the side. Let's just be clear that we're going to let that x be in the numerator, that we'll have the opposite of x divided by y. For when we find the second derivative, we'll be using the quotient rule. Okay. So, to use that quotient rule, we say we'll have the denominator's factor times the derivative of the numerator, take away whatever is the factor in the numerator times the derivative of the denominator, all over b squared. And just like we did before, it might be helpful to identify that a is going to be negative x, a prime is negative 1. B is going to be y. And b prime, well, that's 1 y prime. Now if we plug in that second derivative, it's going to be b, so y, times the derivative of x, or negative x, which is negative 1. Take away from your formula. Leave that factor from the numerator as it was, a negative x, times the derivative of the denominator, y prime, or dy dx, all over that denominator squared. Okay. Well, let's see what we have here. That's positive y times negative 1, negative y. Double negative back there makes a positive xy prime all over y squared. Oh no, just like on TV, but wait, there's more. This y prime. We have something on y prime. We know that y prime is the opposite of x divided by y. We're going to make a substitution. We're going to plug that first derivative in to y prime spot. Okay. When we do make that substitution, what we've got is negative y plus x times negative x over y all over y squared. But look out, that's a complex fraction, and we would simplify that complex fraction if we multiply both top and bottom by this, the LCD. Let's see what we're looking at here. So we've got a negative y, negative x times x up top, and understood 1 times y in the bottom, all over y squared. So I said that there are understood denominators here of 1 and 1. To simplify this complex fraction, we multiply top, bottom, left, and right by y. Okay. When we do, what have we got? We've got negative y squared minus x squared all over y cubed. That is the second derivative.